So we want to continue the discussion about mathematical induction, but if you remember, I gave you two exercises, at least let me solve one of them. So we were supposed to show this cosine x multiplied by cosine 2x multiplied by cosine 4x continued in this way, multiplied by cosine 2 to power nx is supposed to be equal to sine to 2 power n plus 1 times x divided by 2 to power n plus 1 times sine x. Yes?
You're missing that Zoom software though.
Pardon?
That Zoom software though.
No, Zoom, I'm not on Zoom, I'm on YouTube.
Oh, okay.
Who is talking? I can send them a link, but they should inform me in advance, okay? Because Zoom, I am. So I am not on Zoom, okay? I am on YouTube. So this is the link. Okay. Lena, could you hear me?
Yeah.
Okay. Okay. So might be please close your microphone then. Thank you. Okay, so we were supposed to solve this problem. Okay, so let us start doing that. Yeah, so that's a product. We want to show that this product is equal to this. This is an application of mathematical induction in trigonometry, yes? So what we need to do, this is our statement Pn. So what I need to check first is if P1 is true or false. So do you remember what was the point about P1, yes? So what is P1 in this case? Yes?
Cosine. Well, if you've done the pk step before, then it would be cosine k, but I guess cosine x equals. And then
No.
What? No, it's stupid.
That was the point that I mentioned last time.
Wait.
Yes.
I was looking at the number of the question, second question.
No, this question. What I have
It's
written on the board.
cosine a times cosine 2x, I think.
Yes, that should be the case. Yes, because if you plug 1 here, this gives you. I'm not sure if I have written it correctly, but probably yes. So if I put n equal to 1 here, it generates the second term. Yes. So this doesn't mean that you need to write the second term or the first term. So if you remember, you need to start from the first term up to that term. Yes. So if this formula is correct, let us see. This is P1. P1 is cosine x multiplied by cosine 2x. And I am supposed to show that this is equal to sine to the power of 1 plus 1 is 2, 2 power 2 is 4x, and divided by 2 to power 2 is again 4 sine x. So this is P1. Yes? Is that clear? So P1 is not just the first term. P1 is the first one and the second one in this case equal to that. So what can I do here? This is just a math 4 problem. You're supposed to prove this equality. Okay, so I don't know. I usually prefer to start from the right-hand side. So this was one of the cases that P1 itself is not that trivial. So you need to work on it to be able to prove it, okay? So here I would start from the right-hand side of this P1. It's equal to sine 4x divided by 4 sine x. Yes? But if you remember, we had a formula. I don't know where is my blue pen. So we had a formula, if you remember, in Math 4 that sine, I don't know, 2u is equal to 2 sine u cosine u. Do you remember? That is the double angle formula. But it doesn't mean necessarily that you have 2u here. You have to have 2u here and u here and u there. Whatever you have here, half of it you should have here and there. Yes? So it means that if I have sine of something, it should be interpreted in this way. It's 2 times sine of this box divided by 2 cosine of that box divided by 2. So that's exactly the same formula, yes? So for example, if I write sine x over 2, if I want to, I can write it as 2 sine x divided by 4 cosine x divided by 4. So you should immediately realize that that's a correct formula based on that formula, yes? So whatever I have here, half of it I have here, half of it I have here. Okay, so that is the idea. So here, this will play the role of my box here. Okay, so what happens? This becomes 2 sine 2x cosine 2x divided by 4 sine x. Agree? And now, I can use this formula once more for sine 2x. Yes? So what happens? It becomes 2. There is a 2 here. Instead of sine 2x, I write 2 sine x cosine x. And then I have a cosine 2x here. And then here, I have divided by 4 sine x. Yes? Is that clear? Okay, and then what happens? 2 times 2 is 4, and this 4 are cancelled. Yes? And this sine x with that sine x are also cancelled. And then what is left? Exactly cosine x cosine 2x. And that is the left-hand side. So probably this is the first time that checking P1 was also non-trivial. So you need to do some work to prove P1. But if you have a wrong interpretation of P1, then you might think that's wrong. So you need to make sure that you understand that. If I want to check P1, I put 1 here. It generates the second term. So I need to keep the first term and the second term and then equate it to the right-hand side for n equal to 1. Is that clear? Okay. So now that we are sure that P1 is correct, is true, so therefore P1 is true. P1 is true. Okay, then I need to write PK, assumed to be true. So PK is very simple. Just replace n with k everywhere. And by the way, your book has written P. They have chosen P, yes? So 2 to power 2kx is equal to sine 2 to power k plus 1x divided by 2 to power k plus 1 times sine x. So this is assumed to be true, yes? Then what I need to do, I need to calculate and show that pk plus 1 is also true. So pk plus 1 means cosine x cosine 2x up to, I need to replace k with k plus 1 everywhere, so this becomes cosine 2k plus 1. Yes, but you know that by experience, you know that in these kinds of questions, it's better to write the previous one as well. So it becomes cosine 2 to power kx. And on the right-hand side, I replace k with k plus 1 everywhere. So it's very simple. In this case, it becomes k plus 2x. And then I have 2 to power k plus 2 sine x. So this is my question mark now. So I'm assuming that this equality is true. I'm supposed to show that the second one is also true. Okay. So what should I do you think? Yes?
As always, substitute pk into pq as well.
Yeah. So for example, here, it's better to start from the left-hand side of what I want to show and try to reach the right-hand side using this assumption. Yes? So here, the only difference is that so far we have learned about the sum. It's a product. It doesn't matter, actually. So I will start from the left-hand side of what I want to show. I want to start from here. And then you immediately see that from this term multiplied up to this term is exactly what appears in the assumption. And based on the assumption of the induction, this is equal to this expression. Yes? So then it means that instead of this expression, this part using the assumption, this becomes sine 2 to power k plus 1x divided by 2 to power k plus 1 sine x multiplied by another factor here, which is cosine 2 to power k plus 1 x. I would say this is easier than P1 in this case, if you realize what I said here. Okay? You just make a little bit. So here, this one will be multiplied by that one. So this becomes sine 2 to power k plus 1x multiplied by cosine 2 to power k plus 1x, and then divided by this expression, which is 2 to power k plus 1 sine x. Okay, you need to have an eye on the right-hand side. So this is your goal. Okay, now, anyone else? Yes, Alex?
Multiply the denominator and the denominator by 2.
Yeah, that's a good starting point, because you see, this is very good to get some experience. You see, at least it's very clear. Sine x is good. I need it. I have it. Okay, and then the problem is that I need 2 to power k plus 2, but what I have here is 2 to power k plus 1. At least I need to make everything right. So one thing that I need to think about is to change this one to that one. And there is only one way to do that, multiply it by 2. But I cannot just multiply the denominator by 2. I have to multiply the numerator and the denominator by 2. So let me just multiply the numerator by 2. And the denominator by 2. Okay, but if I multiply the denominator by 2, an extra 2 multiplied by that, it becomes 2 to power k plus 2, and then I have sine x. Just one more step is left. Yes, Luba?
Factorize the denominator with the sine to u.
Not factorize, yes? It's already factorized for. I mean, you need to use this formula to write this if you want to. Yeah. Yeah. So it means that I have 2 sine. Let me take this one. Let me give this one the role of the box. And then that's exactly the same box. So if you do not look inside the box, you have 2 sine of the box, cosine of the box. So if I write 2 sine of the box, cosine of the box, what would be the answer? It would be sine of 2 times the box, yes? That's the idea. So this becomes 2 times, sorry, it becomes sine 2 times the box. But if I multiply my box by 2, what would be the answer? It becomes 2k plus 2, yes? It becomes 2 to power k plus 2x and divided by 2 to power k plus 2 sine x. And that's exactly the right-hand side, yes? So that is also a good example. At least it shows that sometimes checking P1 is not that trivial. So you need to do some work to check the P1. Any questions so far? There was also one problem left. Let me also solve that one as well. Okay, so the other problem is this was the problem. So we were supposed to show that cosine alpha. And by the way, one point that I want to mention here, you see that in this expression, 2 variables are involved. One of them is x, the other one is n. I cannot use induction on x, yes? I cannot, for example, say that I replace x with 1 and check this one, even though this is also correct for x equal to 1. But induction only works for natural numbers, yes? N is guaranteed to be a natural number. I just erased that. X can be any number. So I cannot use induction on the second variable. I have to use it on n. Yes? And this is the case here. So you see, I want to write cosine alpha plus cosine 3 alpha. Let me put this in brackets, even though it's not needed. Cosine, the next one is 5 alpha. And then you continue until cosine 2n minus 1 times alpha. We want to show that this is equal to sine of this angle, 2 times n times alpha divided by 2 sine alpha. Yes? So here again, in this problem, I have 2 variables involved. One of them is alpha, the other one is n. But which one is the natural one? N. So you cannot use mathematical induction on alpha, because alpha, this doesn't mean this formula is not correct if alpha is natural. But this is also correct if alpha is not natural. But n is a natural number, so I cannot use mathematical induction on the second variable. I have to use it on the first variable, which is n. Okay, so let us prove this one as well. So here, what is P1? How many terms from the left-hand side I should keep for P1? How many terms? Yeah, just everyone. How many terms?
Just 1.
Just 1, yes? Because if I put 1 here, it becomes 1 alpha, which is alpha. So this is the first term. So this is the only term that I have to keep. So I will check P1. Is cosine alpha, is it equal to, I put n equal to 1 here, it becomes sine 2 alpha divided by 2 sine alpha. So this is what I need to check for checking the truth of P1. Okay, but this is also I think this was the example more or less I gave to in the exam. Yeah. So if you want to solve it, let us start from the right-hand side again. So the right-hand side, I just wrote the formula here for you. Do you remember? So sine of 2 times alpha is 2 times sine of half of the angle times cosine of the half of the angle. And then you divide it by 2 sine alpha. And then it becomes very clear. Because now this 2 and that 2, this sine alpha and that sine alpha are gone. And then you get cosine alpha. And cosine alpha is the left-hand side. So therefore, P1 is true. I'm not just mentioning it all the time. So this is, I'm assuming that this statement is called P of A. Is that clear? Okay, now what I need to do, I assume that Pk is true for some natural number k. So this is the easy part. I just immediately replace n with k everywhere. So this is assumed to be true. Okay, now I need to prove Pk plus 1. So this means that I need to prove cosine alpha, cosine 3 alpha, cosine 5 alpha. And then I continue until then. Okay, I replace k with k plus 1. What should I write immediately? 2k plus 1, yes, because I replace k with k plus 1 and I have a negative 1 at the end. So it becomes 2k plus 2 minus 1. It becomes 2k plus 1, as you said. But you have enough experience in these problems that it is always better to write the previous step, which is the same thing, actually. And then here I need to replace k with k plus 1. So this becomes 2k plus 2. And then the denominator is the same. It's independent of k. So I replace k with brackets around it. With k plus 1 brackets around it, it becomes 2k plus 2. So this is my question mark. I need to show that this is also true. Yeah, this might be a little bit hard. At least the starting point is not hard. Yes, I want to show that the left-hand side of this equation of this equality is equal to the right-hand side. So let me start from the left-hand side. Okay, but now you know what to do, yes? This is more or less always the same. So instead of from here to here, I just take it and put this expression in, yes? So this becomes 2 sine 2k alpha divided by 2 sine alpha plus this expression, yes? Yeah, this needs a little bit of experience, a little bit more experience in trigonometry than you gained so far in Math 4. But at least the starting point is not that hard. By having an I on the right-hand side, you see that I have only one fraction, and the denominator of this fraction is 2 sine alpha. So it motivates me what to do. Yes, it motivates me to take the common denominator. Yes, so then I would take the common denominator to be this one. Okay, and then this divided by this is just 1 times the numerator is the same. But then the denominator of this is actually 1, so it is 2 times sine alpha times. I multiply it in the numerator. Okay, so that is the tricky part. So what I need to do, I need to be able to show that the numerator of this is equal to this summarized form. Yes, because if I want to make sure that this is equal to this one, the denominators are already equal. There's only one way to prove that the numerator is actually equal to this numerator. Okay, so that needs a little bit more experience. Okay, so let me teach you and change the color. So let me, I don't know, do you remember this or not? So you have sine of u plus v. There was a formula for sine u plus v, addition formula. So I can just write it as sine u cosine v, yes? And then minus a plus sine v cosine u. Yes, that was the formula we already know. And there's also another similar formula for sine of u minus v. Yes, so this is what? This is sine of u cosine of v minus sine of v cosine of v. Agree? Okay, if I add them, what will happen? This becomes sine of u plus v. This becomes sine of u minus v. But on the right-hand side, these two will cancel out. And then these two are exactly the same, so they will add up, yes? So it becomes 2 times sine u cosine v. Agree? And that is the motivation why I did this, because you see, what is this combination? The combination that you see here is 2 times sine alpha, but not cosine alpha. Cosine of another angle. And that's exactly helpful here, yes? Because this gives me a relation for 2 times sine of an angle, cosine of another angle. It becomes sine of this, yes? Now, so this is the formula that I got. Now let us go back to the problem itself. So in the problem, alpha is my u, yes? So if I replace u with alpha, and if I replace v with that expression, yes, then this tells me that sine of u plus v, which is alpha plus 2k plus 1 alpha, and then u minus v, which becomes plus sine of alpha minus 2k plus 1 alpha, is equal to 2 sine, instead of u I put alpha, as I did there, and cosine of 2k plus 1 alpha. Okay, so let us wait a little bit. So what I have done, we had this in Math 4, we had this in Math 4. What I have just done, I simply added these two relations, yes? And then you see that how should I use this one? How can I use this? What I'm saying is that I want to have this combination. So this motivates me to replace u with alpha to make sine u exactly equal to sine alpha. And I replace v with this expression. So what I have done is here. So this formula is valid for all possible choices of u and v. So if I want to, I can replace u with alpha. I can replace v with this one. So is that understandable so far? Yes? Okay. But now let me simplify this expression a little bit here. So how can I simplify this expression? So you see, if I factor alpha out, so what is left? This is 1. This is 2k plus 1. Agree? If I take alpha out from this one and that one. I'm of course, there's a sign here as well, but I'm just talking about this. But 2k, 1 plus 1 is what? 2k plus 2 alpha. Agree? So that part is the sine of 2k plus 2 alpha. But let us check this one here as well. If I factor alpha out, okay, can you tell me what is left from the first one? What is left? 1. And what is left for the second one is minus a pair of brackets 2k plus 1. But then if I open that pair of brackets, what will happen? It becomes minus 2k minus 1. Do you agree? If I just factor alpha out. Understandable or not? Okay. And then this minus 1 and that 1 are cancelled. So what is left for me is minus 2k alpha. Okay, so let me write this. Okay, so what I get here, this tells me that, therefore, two sine alpha cosine 2k plus 1 alpha so this one, this expression, is equal to sine of this yes? Okay, now can you tell me what can I write instead of sine of minus 2k alpha? Do you remember what was sine of minus theta?
Minus sign.
Minus sine. So if it was cosine minus theta, it becomes cosine theta, but sine of minus theta is minus sine theta. We had it in math form, yes? So now, instead of sine of minus 2k alpha, I can write negative sine of positive 2k alpha, yes? So this becomes negative sine of 2k alpha. So we are done, yes? Because instead of this one that I have put this in this blue part, instead of this expression, I am allowed to put this expression, but this minus sine 2k alpha will cancel this one, and what is left for me is this one, and that is exactly the right-hand side that I wanted to show. Unfortunately, I erased that. Yes? So this means that therefore, the left-hand side is equal to, so sine 2k alpha plus, instead of that one in the box, I put this expression. Yes, and then I have the denominator 2 sine alpha. But then you immediately see that I get rid of this extra part that I don't need, and then I will get to sine 2k plus 2 alpha divided by 2 sine alpha. Yes, and that if you check your notebook, you see that that's exactly what I wanted to show, and that's the right-hand side. So that would be a little bit tricky because might be you didn't have that experience to use these formulas in this way, okay, in this way. Okay, so now let us, any questions so far? Okay, now let us start the new ones. So now, proving inequalities. So all of them are in the book actually, okay? So now let me erase this part. This is not something extra, it's not above the book, okay? So of course, they also have some trigonometry identities in the book, I think. So proving inequalities, yes. So let me start with an example. Of course, the idea of mathematical induction is always the same, but I want to give you the diversity. I want to expose you to the diversity of the problems that you can use mathematical induction to prove them. So we talked about equalities, these kind of equalities from algebra and from trigonometry. Okay, now I can just show you some examples from inequalities. Okay, so let us prove this one. So example, let x be a real number such that x is greater than or equal to -1. It's a real number, so it can be -0.5, it can be, I don't know, square root of 3, whatever. Show that for any natural number n, we have 1 plus x to the n is greater than or equal to 1 plus n times x. So let me emphasize that here I have mentioned that x is real, but n is natural. So can I use mathematical induction to show this problem? Might be, but I know that I have to use mathematical induction on a natural number. So if I want to choose mathematical induction as a tool to prove this problem, to prove this inequality, I have to use induction on n. I am not allowed to use induction on x, yes? So you need to replace n with 1. It doesn't mean that this is not valid for natural numbers x. It is valid for natural numbers x as well as real numbers. Okay? But n, you cannot start induction on a variable whose domain is not the natural number, is not the set of natural numbers. Okay. So let us see why I am just giving you example, because it needs a little bit of experience here. Inequality, it was clear what I need to do. I need to start from the left-hand side and exactly reach to the right-hand side. But in inequality, that's not an obligation anymore. Yeah, just let us start, and then I will ask questions. So if I want to show this, just help me to do that. Okay, what should I do? I do that first. This is my Pn, so I give it a name. So let me change my color here. So I will call it Pn. Then I need to check the truth of P1. Is P1 true or false? So first of all, I need to write this statement for P1. What is the statement for P1? It's x1 plus x to the 1 is greater than or equal to 1 plus 1 times x. That is my question mark. So this is the question mark. But this is trivially valid, yes? Because what is 1 plus x to power 1? So this is equivalent to 1 plus x is greater than or equal to 1 plus x. Agreed? So this is my statement for P1. I just algebraically simplified this expression. So 1 plus x to power 1 is 1 plus x. 1 times x is also x. Is this true or false? 1 plus x is greater than or equal to 1 plus x. Is it true or false? True or false?
True.
Okay, so it's true. Okay, now I need to write pk and assume that this is true. So pk, let me write with this blue one here again. So pk assumed to be true. What is pk? It's very simple. Again, the same scenario. I just replace n with k everywhere. Assumed to be true. What is pk plus 1? I need to replace k with k plus 1 everywhere. So this becomes k plus 1 is greater than or equal to 1 plus k plus 1 times x. And this is the question mark. But this is not equality. So I cannot say that I start from the left-hand side and reach exactly to the right-hand side. That's the only point that you need to be careful. Yes? Okay. So what do you think I should do? So have it in mind that your assumption is an inequality. What you want to prove is also an inequality. Okay, so I don't know, you need to find a way somehow to come from here to here. So any opinions? Okay, so let us start to see what I can do. I should start from what I know it's true and try somehow to reach to this one, to conclude this one. It's not a good word to say to reach this one, right? I cannot reach exactly to this one, but I should be able to conclude that one is also true. So this is my assumption, so I can trust this statement. Somehow I want to get something similar to this expression, okay? So what is this one? If I see the left-hand side of what I want to show, I see that there is one factor of 1 plus x is missing here, yes? So this might motivate me to multiply both sides by 1 plus x. Okay, first of all, am I allowed? So let me write something like this, then I will ask you. This is true, assumed to be true. What I do, I multiply both sides by this expression. First of all, is it a mathematical legitimate way of doing or not? Because inequalities, for multiplying both sides of inequality, should be careful. This is not like equalities, yes? So this becomes 1 plus x, 1 plus kx. So what I have done, I have multiplied both sides of this inequality, which I am assuming to be true, by a factor of 1 plus x, and I am concluding this. First of all, I need to check this. Is it a valid way of arguing here? Is it possible to conclude from here to here? No one else? Yes, Luga?
I think it's valid.
Why?
I think you only need to be careful when multiplying with negative numbers.
Yes, and it is not, it's guaranteed to be not negative. Why? It's given in the assumption. So that's why this is given here. Because x is greater than or equal to -1. If I move -1 to the left, it becomes 1. This is x. It becomes greater than or equal to 0. So what I am multiplying on both sides is guaranteed to be non-negative. If it is guaranteed to be non-negative, I am allowed to multiply and keep the direction. If it is guaranteed to be negative, still I am allowed to multiply, but I need to remember I need to reverse the sign. If sometimes it is positive, sometimes it is negative, then it is not clear. I'm not allowed to multiply. So this is correct, so I can just clean this question mark. That's valid. The good point about this is at least the left-hand side reads exactly the same. Yes, so this becomes, therefore, 1 plus x to power k plus 1. This is what I have written instead of that, is greater than or equal to. So what should I do for the right-hand side? The first motivation might be is to multiply this. Let us do that. So 1 times 1 is 1. 1 times kx is kx. And then x times 1 is x. Then x times that one is kx squared. Let me write it one more step. So it becomes 1 plus x to power k plus 1 greater than or equal. That is the point that I want to teach you here. So this becomes 1. If I factor an x out here, it becomes k plus 1x. But this will remain there, yes? That's k is x squared. So do you think this is a failure or is a triumph? So because you see that the left-hand side is exactly the left-hand side, but the right-hand side is very close to this one, but unfortunately, I have this extra term hanging around there, okay? So what I'm saying is that I want to tell you this. Yes, we are done, and that is correct way of doing, but you need to tell me why. Even though this is not exactly what I'm supposed to have on the right-hand side. Yes?
If it's guaranteed to be greater than
Yeah, exactly. Yeah, thank you very much. And that's guaranteed. Yes, because you see, my goal was to show that this one is bigger than that one. I didn't succeed to do that, but I did better. Yes, I proved that this one is bigger than this one, and this one is guaranteed to be bigger than that one. Why? Because x squared is non-negative and k is a natural number. So it means that even though I was not able to exactly show this inequality, I showed a stronger inequality, which is better for my case. So this is what you need to remember for proving inequalities. Don't think that what you get on the right-hand side should be exactly what you want to get. You might have proven a little bit stronger one. So from that stronger inequality, of course, you can clearly conclude this. Okay. So let me write it here for you. So let me describe it in this way. So assume that my goal is to show that A is greater than or equal to C. Assume that this is my goal. Okay, I want to show that A is greater than or equal to C. If I can show it directly, okay, good. But if I cannot show that, and if I show that A is greater than or equal to B, but I should, and somehow I can show that B is also greater than or equal to C, do you think that I am done? You see, my goal is to show that A is greater than or equal to C. Assume that I wasn't able to get this directly, but I was able to get this one directly. And then if I can show that B itself is also greater than or equal to C, then immediately I can conclude that. So that is the idea, what I'm saying here. I'm supposed to show that this is greater than this, but I succeeded to show that this one is greater than this. So then I would write this. So let me put this in a box here. So then I would say that, but 1 plus k plus 1 times x plus kx squared is greater than or equal to 1 plus yes, since k is a natural number and x squared is non-negative. If you want, that is the reason. Therefore, this one is greater than this one. This one itself is also greater than this one. Exactly like this, I can conclude that 1 plus x to power k plus 1 is greater than or equal to 1 plus k plus 1 x. So that is the whole point, actually. This is the only new thing that I want to draw your attention when you are using mathematical induction to prove inequalities. Is that clear? So you need to keep it in mind. There is no reason that you need to force yourself to get exactly the right side. You might get a better or a stronger inequality. Is that clear? So let me give you another example. Okay, so let me mix these two methods. Yes, so example. For any natural number n, show that. So let us do this together. Yes, 1 plus 1 over 4 plus 1 over 9 plus up to 1 over n squared is less than or equal to 2 minus 1 over n. So I will go through it slowly, but please try to interact with me so that I'll make sure that you understand everything. Okay, so that's actually a combination of these expanded formulas with these 3 dots and inequalities. Yes. Yeah, something similar to this is also in the book. Okay, so the first thing that I want to do, this is my statement Pn. So let me call it Pn. And then I need to show that P1 is true. So first of all, I need to write P1 properly. Okay, can you help me to write P1? What is P1? Someone else? Yeah, why don't you just participate? Yes, please.
1 is less than or equal to 2 over 1. 2 minus 1 over 1.
Exactly. So it's very good to write it in the exact way. You cannot just write 1 is less than 1, okay? So why P1 is the only one? Because when I put 1 here, it becomes 1 over 1. That's exactly the first term, yes? So it means that I need to keep the first term on the left-hand side, and I replace n with 1 everywhere. So this is my question mark, but this is true or false. Just need a very simple calculation. The left-hand side is 1, less than or equal. 1 over 1 is 1. 2 minus 1 is 1. So is it true or false? It's true, yes. Okay, now pk. Pk is the simplest one, yes? You just replace letter A, n with k everywhere. Just let us do it quickly. So this is assumed to be true, yes? What is pk plus 1? So pk plus 1, I need to replace k with k plus 1. So let me, yeah, you have experience, so let us put an empty space here. So I need to replace k with k plus 1. So if I go from 1 up to k plus first term, so it means that the previous one is the kth step. Yes, it's k squared. And on the right-hand side, I have this. So this is the question mark. Question mark for an inequality, not equality. So this is assumed to be true. Somehow I need to manipulate this a little bit in a valid way so that I can conclude this. Okay, so what can I do? Yes?
I try the trust the trick to substitute pk plus 1.
Substitute is not a good word here because substitution happens if we have equality. So this means that I will I will take it and replace it with what is equal to that. But here I cannot say I replace it. So you need to change the logic a little bit. Someone else? So replacement is not a good word because this is not equal to this so that I can take this one away and put it here. I want to take this away and I want to put this one, I agree with you, but I need to justify in this inequality, yes? Because this is not equal to that, so that I can replace it with that expression. So for example, you can start again from the left-hand side here. Let me write something for you here if you see that that's okay. So this, let me write it everything. 1 over 1 plus 1 over 4 plus 1 over 9 up to plus 1 over k squared plus 1 over k plus 1 squared. Okay. I want to write that this is less than or equal to 2 minus 1 over k plus 1 over k plus 1 to the 2. Do you agree with this one? Is that clear now? Because the assumption tells you that from this number to this number, it's guaranteed to be smaller than this. Yes? So you see, this part is smaller than this part. And then I add this expression to both sides. So this is a valid argument. Is that understandable? So in other words, if you don't like this argument, you start from what you know, you add this expression to both sides of this inequality, and then you get that. Yes?
No, I think I was trying to think of a way to formulate.
Yeah. You are free, but this is not what this doesn't mean that whatever you write in the exam, I agree with that. If there is a logic to that, I agree with that. And if I'm mistaken, you can just come back and just have appeal to that. But then we need to discuss. Okay, so do you understand the logic that I used here? Yes. The expression. So forget about everything here. I have written one expression, algebraic expression here. And I am telling that from this part to this part, it's guaranteed to be smaller than this. Yes? So do you agree that the whole expression with this one is smaller than or equal to that expression, which this part is equal than less than that, plus this expression? Yes? If you don't like this logic, consider this one and add. So you see, if I have A less than or equal to B, and then I can write A plus C is less than or equal to B plus C. This is logic, yes? Yeah.
Could you say that you're shifting the inequality in a direction by adding?
I don't want to make these things complicated, okay? I'm just adding a number to both sides of inequality, as simple as that. Yes? No, I haven't reached to that yet. So that's what I'm saying.
So this is PK, not PK plus 1.
No, this is PK plus 1, the left-hand side of PK plus 1. Okay? But what I have done, I am just telling you this simple idea. Do you agree that this is smaller than this one, or yes or no? That's the only question that I'm asking. Is that clear that this should be smaller than this? The answer is yes, because this part is guaranteed to be smaller than 2 minus 1 over k. Yes? So it means that if I add this to this, definitely it's smaller than this one. If I have a number smaller than b, I can immediately conclude a plus c is also smaller than b plus c. That's the same idea. But it is not finished yet, because what I showed that this expression is a smaller or equal to this, smaller than or equal to this expression. But I am not done yet, because I am supposed to show this, not that. So it is not finished yet. Is that understandable? Unless I can do something. What? Unless I do some algebra and coincidentally this exactly becomes equal to this, which in this case it does not. Or I should prove something else. If I can show that two minus 1 over k plus 1 over k plus 1 to power 2 is itself is less than or equal to what I want to show, then I am done. Then we are done. Then I am done, yes? So I just want to understand the logic. Is what I am writing clear for everyone? So my goal was not to prove this inequality. My goal was to prove this inequality. So it means that I am not done yet. But what I'm saying is that if I succeed, it's not guaranteed yet. If I succeed that this one itself is smaller than this one, then I am done. Yes?
Shouldn't it be greater or equal?
No. See the logic? This one, so let me ask you something. Do you trust this inequality? Let us repeat everything. Do you trust this inequality, yes or no? Just say yes or no.
Yes.
Everyone, yes. Do you trust this inequality? Not yet. Yes? No. Do you trust this inequality?
Yes.
Yes. Because this is a consequence of this inequality, by adding the same number 1 over k plus 1 squared to both sides. That is also trustable yet. But unfortunately, this is not what I want to show. I want to show this one is smaller than this one. What I am saying is that I know that this one is smaller than this one. If this one itself is smaller than this one, if I have these two, what can I conclude? If I call this one A, if I call this one B, this is trustable. If I show that B itself is less than C, A is less than or equal to B, if I can show B is less than or equal to C, from these two I can conclude that A is less than or equal to C, and then I am done. So this means that I reduce the problem to an algebraic problem. So forget about induction anymore, because I just want to focus my energy to prove this inequality. Yes or no?
Yes.
Is it hard to see? Because I don't know, you need to contact with me, okay? So the way that I am looking at you, it means that you don't understand. Is it hard to understand or not? You can save my breath, yes? Do you understand it?
Yes.
Yes or no?
Yes.
Yes, okay. Okay, so then I am done. So this means that forget about everything now. Just try to prove this one for yourself. Okay, so let us see how can I prove that. Inequalities are usually very hard to prove. So I really don't know how should I prove it until I simplify it, until I reach to some point that it is guaranteed to be true. Okay, so that's the idea. So what is the first thing that I can do here? I can say that this statement, which is a little bit complicated to understand, is equivalent to, I can just drop these two from both sides. Yes, this becomes minus 1 over k. So I am just simplifying this inequality. But I will talk a little bit more here. The simplification should be reversible. It's very, very important. So it means that I am simplifying these two. From here, I get here. But this is also reversible. I can add a 2 to this. I come back to the same point. So it is very important when you are simplifying your inequality to reach to a simpler inequality, these operations are all reversible. Okay, for example, what can I do here again? I don't know, which for me, always working fraction is not very pleasant, so I just get rid of fractions as soon as possible. So I myself multiply this by k times k plus 1 to power 2. That's up to you. But can I do that? If I multiply everything by k times k plus 1 to the 2, the reason for this doing is I just want to get rid of fractions. If I multiply this by the first term, it becomes negative k plus 1 to the 2. Yes? And then if I multiply this by that one, k is left. K multiplied by that is k. And then this becomes smaller than or equal. If I multiply that with that, it becomes minus k times k plus 1. First of all, is it possible to multiply by this? Yes or no? You need to check every step. Why? Because when I am multiplying an inequality, I have to be careful. This number should be non-negative or should be negative so that I know what to do. But in this case, I know that this is positive because k is a natural number. That's also positive. So it means that when I multiply, I can keep this inequality in that direction. Okay. But still, it is not that clear. Is it true or false? But important thing, is it reversible? This is the most important thing. Yes, because I divide by this, I go back to this one. It is reversible. But let me simplify because still I cannot guess. Let me square it and then multiply this negative sign inside. So it becomes negative k squared, negative 2k, negative 1 plus k. And let me multiply that one as well. So it's minus k squared minus k. So I can conclude this. It is also reversible because I can collect it back. Okay, so let me continue here. So what can I do here? You see, I can simplify this minus k squared and that minus k squared. Okay, and then see what happens. If I take minus k to the right-hand side, so let me simplify. Minus 2k plus k is minus k. and then I have minus 1, is less than or equal to minus k. And that is also reversible. And now if I move minus k to the right and 1 to the, for example, 1 to the, it doesn't matter actually that much. So minus k, I move it to the left, it becomes positive. I move this 1 to the right, it becomes 1. So that is also reversible. But then what happens? This becomes 0 less than or equal to 1. That's also reversible. So in mathematics, you need to you see, for the time being, I have trained my brain in this way. When I'm doing here, I just totally forget about what was before that. I just focus my energy to prove this one. Unless I have a good reason that I have done some mistakes, I have to go back and check it. Okay, so what is the logic? The logic is that when this is reversible, it means that these two are equivalent. This statement is equivalent to this statement. What does it mean? It means that they are simultaneously true or they are simultaneously false. Okay, so this one is equivalent to this one. Still, I don't understand why this should be true, so I continue simplification. I continued my simplification until the very last step. But is this trivial or not? Is it trivially true? So this is true. This means that this statement is equivalent to the statement that I want to show. But I know that this is true, so the starting point was also true. It's very, very important. If you just go in one direction, it means that this one implies a correct thing. But I want to start with a true statement to conclude that one, because still I don't know if this is true or not. Okay, so then I am done. I don't know, is that understandable or not? Yes, everyone?
Yes.
Yes.
Okay, so that is something that you need to deal with when you are proving inequalities. One more thing is that sometimes when you want to prove some inequality, usually this happens in inequalities, but that is a general statement. So sometimes the induction doesn't work for 1, doesn't work for 2, doesn't work for 3, but suddenly after 3 it will start working. Okay, so sometimes this happens. So it means that the base of induction can start with a different number except than 1. Yes. So for example, for some reason you check the statement is true for n equal to 4. And then you prove that if pk is true for k greater than or equal to 4, then pk plus 1 is also true. So it means that I am able to show that this statement is true for all possible values greater than or equal to 4. So this is not just, so this is something that I want to teach you here now. Let me give an example. Let me start from that side. Are you tired? So good, we can continue, yes, because there is no other way. Week 49, I will try to talk to, I think, Nadim. The aula is occupied by Nadim, I think. BIO means biology, yes? The lesson. So I will talk to Nadim and probably I will put the exam on week 49 Thursday. But as soon as I talk to Nadim, I will tell you, I will let you know. Okay, so let us write this expression for you. Show that, a simple one. Example, let me continue this one, sorry, because we have to finish it. Example, let us show this inequality. For any natural number n, n greater than 4, show that n to power 2 is less than 2 to power n. Okay, So this is the first example of this type that I am talking. You see, I am not saying prove this inequality for all natural numbers. Might be this is not true. Of course, is it true for n equal to 1? This is equal to, yeah, for n equal to 1, it is true. But for n equal to 2, it is wrong. Yes, because 2 to power 2 less than 2 to power 2 is wrong. For n equal to 3, that's also wrong. Yes, because 3 to power 2 is 9, and 2 to power 3 is 8. So 9 is smaller than 8 is wrong. For n equal to 4, it still is wrong. Because 4 to power 2 is 16, 2 to power 4 is also 16. So you see that even though P1 was true, but I was not able to conclude that the other ones are true. But this is claiming that this chaos will not happen if I just look at numbers greater than 4. It means that it will continue to follow this pattern from number 5 actually, and greater than 4 means starting from 5. So the first number that I need to check is not P1. I need to check the truth of what? P5, yes. That is the only thing that I want to talk about. So P5 means 5 to power 2 is less than 2 to power 5. But this statement itself is equivalent to, because 5 to power 2 is 25, less than 2 to power 5 is 32. This is true. But here you need to be a little bit careful. I cannot just say PK. So you can write PK, but you need to have it in mind that this K satisfies the condition. Yes? So you should say that this is the statement, let K belongs to N and K be greater than 4. Okay? And now we assume that PK is true. So it means that we know that K squared is less than 2 to the K, assumed to be true. Then what is PK plus 1? PK plus 1 is K plus 1 to the 2 is less than 2 to the power of K plus 1. This is your question mark. Everything that I have told you can just repeat it, except that you have this in mind that K is greater than 4 whenever it is needed. Might be at all, you don't need it at all. But in case you need it, you need to know that K starts from 5, 6, 7, etc. Okay, again, this is today's lesson. I want to prove an inequality. I don't know, how do you want to prove it? Equalities are easier to think about them because the method is always clear. You start from one side, you go to the other side. But for inequalities, might be you need to be a little bit more creative. Yes, Alex?
I start with the statement of PK, and then I times it by 2.
Yeah, that is the first thing that I wanted to do myself, because I want to go from here somehow to conclude this one. Either I need to make this one somehow equal to this by some method, or I need to change this one to that one. At least this is a good starting point. I'm not saying that this 100% will work, but that is better than nothing. Yes. So which one is easier? Might be multiplying this by 2 is easier. Yes. But then you should have the logic in the back of your head. So I would say that K squared is less than 2 to power K. Can I trust this? Yes, because it's my assumption. And somehow I want to conclude this. So this motivates me. Yes?
Can I give a rough guess? Will this include induction within induction?
This is also some of the problem, but I don't include them. Yes, I don't include them because they are not in the book. Okay, so what happens? I multiply 2 itself, so it becomes 2K squared is less than 2 to power K plus 1. So do you agree? Is this reliable or not so far? Yes, because I started from what is reliable. Why? It's the assumption of the induction. I multiplied this by 2, and I know that 2 is a positive number, so I can rely on this inequality too. But unfortunately, this inequality is not exactly what I want to show. Okay, so then you need to think logically. What can I? So just tell me, because then I can relieve that you understood. Someone else, yeah, please. I want to show that this is smaller than this one, but I couldn't. I could show that this one is smaller than this one. If I can show, okay, you just tell me. If I can show ... I am done. Yeah, may you please fill up this gap? Yes, please.
K squared is smaller than k plus 1 squared.
No. Think a little bit. That is what you want to show. You are on the right track, but you miscalculated something, I think. So you see, your goal is to show that this is smaller than this one. I want to wait for you because I think you can fix it, yes? So you need to write something here in this, so that comparing this one with this one gives rise to that one.
So k squared multiplied with k plus 1 squared is...
No. That one, the previous one was better. No, but let me see. You see, you want to write what you said. Let me write it here. You said to prove what? What you said before?
K squared is smaller than k plus 1 squared.
Okay. Now let me tell you something. Assume that this is A. Don't confuse you. Let me say this is A. This is B. Okay, if that is A, this is again A, this is the same expression, and this is a new expression, let us call it C. What I have is A is smaller than B. If I have A also smaller than C, do you think that I can conclude that C is smaller than B?
So if c is smaller than
No, my point is to show C is smaller than B. This is what I want to show. So you need to write something so that from this one and that one, you can conclude C is smaller than B. So what should I write here? A is smaller than B. What should I write here so that I can have a guarantee that this is also true? A is smaller than B. Yes? Yes?
A is larger than or equal to C.
Yes, so it means that C is less than or equal to A. Yes? Because now, if I know C is less than A, I also know that A is less than B. So it means that I can logically conclude that C is less than B. Yes, do you agree? So that was the guess. This is not hard. You need to be patient, not tired. Guess, think a little bit. You can discover it yourself. So if this I know, this I want to show. This didn't work. The one that you said doesn't work. Yes, you see. Just think logically. A is smaller than B. Sorry. A is also smaller than C. You see, this is A. I know that A is smaller than B. It's on the left-hand side. I know that A is smaller than C. But you see, B is not smaller than C. It might be. C is here, but there is no guarantee. I want guarantee. You understand? So this means that this will work. If C is smaller than A itself is smaller than B, then we can immediately conclude that C is smaller than B. So what I want to put here is this expression. This I clean it and correct it. So it means that I need to show k plus 1 to the 2 is less than 2k squared. Yes? Now see, if this is true, this one is smaller than this one. We also know that this one is smaller than this one. So it is clear that this one is also smaller than that one, and that's exactly what I want to show. Yes?
Would it also work if it was less than or equal?
Yes, that's better. Yeah, thank you very much. Let me write it here in this way. Because if that's also equal, then that's okay. Yes, that's actually the thing that I need. Thank you. Because if A is smaller than B and B is less than or equal to C, then it means that A is also less than or equal to B. No, sorry, this guarantees that A is less than B. They cannot less than C. It cannot be equal to C because one of them is a strict inequality. Anyway, so if I can show this, then I am done. But this is very simple in this case. It is. I don't know this is guaranteed yet, so I need to simplify it in a reversible manner. So what should I do? I can expand this. It's k squared 2k plus 1 is less than or equal to 2k squared. Okay? It is also reversible. Here, I can do what? For example, I can move k squared to the right. It becomes 2k plus 1 is less than or equal to k squared. But this is also still not guaranteed, is it? What can I do now? Yeah, so I simplified this expression and I got that one. But do you think this is now guaranteed to be true or not? So I need to make sure that this is possible to show that. So I don't want to make another induction in induction, so it shouldn't be that hard to prove it. Do you have a good idea how we can convince ourselves that 2 times k plus 1 is always less than or equal to k squared if k is greater than or equal to 5? Yes?
K plus 1 squared.
May you speak louder, please?
K plus 1 squared equal or less than 2k squared. Which one A, which one is B, which one is C? Like, is it A, B, or C?
Forget about A, B, and C. So you need to convince yourself that if I show this, I am done. Because this one is smaller than this one. If I can show, I also know that this one is smaller than this one. So this is smaller than this one, this is smaller than this one will give me this one is smaller than that one, which I want to show. You don't need to confuse yourself that much. Yes? Yeah.
Just divide both sides by k again.
By k?
Yeah, and then you get 2 plus 1 over k is greater than k. And that's and if we know that k is greater than.
So let me see that. So you are saying that I divide by k, so it becomes 2 plus 1 over k is less than or equal to.
Yeah, and then because we know that k is always greater than 4.
Yeah, that's good. That will work. Thank you very much. So this is one way to do that. Because Alex is saying that I divide both sides by k, this becomes 2 plus 1 over k is less than or equal to k. But is this guaranteed to be true? I would say yes. Because 2 plus 1 over k
will never get greater than.
Yes, it is always a number less than 1. Yes, because k is greater than 4. So 1 over k is less than 1. So it cannot reach to 3. So it's always smaller than 3. But on the other side, we know that k is always bigger than 3. So this is trivial. So you see, this was crucial in this statement. Yes, so this idea was important. So yeah, I just talked about that orally. You might also find another way yourself. Couldn't we say the same thing here? So I would say that what is the minimum value? So the minimum here, the minimum of k squared, what is the minimum of k squared? Is 25. Yes, because k is greater than 4, so the minimum, minimum is 25. And then 2k plus 1, so what is the maximum? But I think this is easier. Okay, so I didn't know that we have time. So I will continue a little bit this next time. Okay. Yes? Here there is no maximum. No, there is no maximum. But this one is good. Because this 2 plus 1 over k is definitely smaller than 3. This is definitely bigger than 4, so that's 3. Thank you very much. Okay.